This recording is for Primary Math 6. We're working on the class recording for week 1, and this week we're working the workbook. Of course, this is workbook 6A, exercises 1 through 3, intensive practice 6A, pages 1 through 5, and challenging word problems, page 1 through 7. Now, I hope you had a chance to watch the intro to Primary Math 6 because it has some very important information in it, and I, especially for Primary Math 6, would like you to watch it. But, and probably you're not coming in Primary Math 6 for the first time with Singapore Math Live, but maybe, and because many people don't normally start Singapore Math in Primary 6, but maybe you didn't have support until then. So let me explain it a little bit. Challenging word problems are always done in a separate recording as a solutions recording, so you'll see that in a separate recording, and that'll always be listed when you have challenging word problems. It'll be listed as a separate link, and those I'm just working through all of the problems on those pages. All you need to do is click on that link and watch the fast forward to the one you need to see, and you'll find that. The workbook is always discussed in the class recording, this recording, and I'll make sure you know what's going on, what topic you're talking about, and all the kinds of things you'll need to know. The intensive practice sometimes goes one way, sometimes goes the other way, depending on what it is. If it's word problems, because each intensive practice has some practice and then goes on to some word problems, the word problems also have a separate recording. But in this case, intensive practice just has practice, and so it'll be in this recording for the class recording. So if it is word problems, it's a solutions recording. If it's not, it's in the class recording. And anytime you're watching one of these and you don't have the help that you need, send me a question or a message, an email, and let me know what you're struggling with. I'll be happy to add another recording and put it up for you, or talk to you if you just have a quick question. We can figure it out. The first week, our topic of all things, we jump right in and we talk about algebra. And so this is the very first time we've talked about this topic. Some of you see that word on your syllabus and you are quaking in fear, and some of you think that this is fun. You're finally to the good stuff with your student. I'm going to be pretty wordy in this recording. Most recordings won't be quite this long, but I'm going to make sure that if you are in the first group, if you are needing to be talked off the ledge because the syllabus says algebra and you're working with your student and you're not really sure about algebra, that you have the help that you need. If you are comfortable with teaching algebra and the way you would explain this to your child, then much of this recording you won't need to have, and you can fast forward and just watch a little bit, and if I say something interesting you can go back and listen to it again. But I just want you to know, fair warning, it's going to be a little bit more lengthy than other times because I just am aware of the fact that it's algebra might make us a little bit nervous. Okay, so in the workbook, exercises 1 through 3, we just want to get used to the fact that if you weigh a watermelon, this is my very fancy scale, I'll make my watermelon green. If you weigh a watermelon on the scale, according to the information it gives us, okay, here's my tray the watermelon sits on, here's the other tray, according to the information it gives us, if I put a weight down here of m kilograms, the scales are exactly balanced. You see how they're balanced? Okay, those scales are balanced because a watermelon is equal to m kilograms. Now m might be 5, m might be 25, right? We could have a really, really heavy watermelon, but it balances that way. And we're told, second piece of information, that we have another scales over here. And in this one we have a pineapple, and the pineapple weighs 2 kilograms. Okay, and so if we want to express part A, express the total weight of the fruit in terms of m, that means we're going to say the weight is equal to m plus 2, because if I wanted to make a total weight, then I would have to put the watermelon and the pineapple. I'm a really excellent artist, you'll find that out soon enough. The pineapple and the watermelon have to go together, and in that case the way to balance it out would be the m weight and the 2 weight together. So that's why the weight of the fruit is equal to m plus 2, and then we get to actually use that in application. Part B tells us that m is 4. Well, okay, if you tell me now, instead of m, if you tell me the weight of the watermelon is 4, the total weight of the fruit, we just said the weight is m plus 2, and what you've just told me is that m has a nickname. Now, here's what I tell students all the time. It might be helpful. If you and your family come to my home and the kids are playing and one of your kids comes to me and says, Mrs. Barnett, may I have a drink of water? And then you say to me, Brenda, don't worry about it, I'll get it. And then my child says to me, Mom, it's okay, I'm getting some water, I'll get it myself. In the course of a very short period of time, somebody's called me Mrs. Barnett, somebody's called me Mom, and somebody's called me Brenda, and nobody falls out of their chair and has a problem with the fact that I've just been called 3 different names in the course of a short period of time. And that's what I want our kids to get used to when we use letters to substitute for numbers. The point is m has a nickname. If the weight is m plus 2, and if the nickname I'm using for m is 4, then the total weight is 6 kilograms, right? Part C. Let's let the nickname for m be 6. We're saying they're equivalent. It means it's the same thing. It means I can use 6 as a nickname for m. So if the weight of the fruit is equal to m plus 2, and a nickname for m is 6, then I can say that the weight is 8 kilograms. By the way, always have your student answer a math problem with units, and always have them put the answer in a box at the end of the page, or at the end of the problem. Now, again, we're not going to go through every one of them this completely. We just want to make sure we understand. Suman bought a book and a pen for X dollars, and the pen cost $5. So I'm going to make a box diagram, a little bar model. We know that the total amount here is X. And I know that the first part he bought is a pen, and the pen is $5. And then the rest of what Suman bought at the store is a book. Now, it wants us to express the cost of the book, that's this part of the graph, in terms of X. What that means is I want to say book equals blah, 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 X. Maybe blah, 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 blah. There's going to be an X in the answer. Book equals something. It's going to have an X in it. That's what we mean by in terms of X. And so here's the point. If I take the, if I want to know the price of the book, I can take the whole thing, that whole thing is X, and I can remove from it, take away that $5 that you spent on the pen, and that's going to give me the leftover, which is the price of the book. And then, of course, in B and C, you're going to use a nickname for X, be that 11 or 15, to solve for the price of the book in that case. These problems are very carefully done. You might notice we just added, then we subtracted. Now guess what we're going to do? Meihua bought 3 t-shirts at N dollars each. So here's a t-shirt. I paused and drew those. I hate to have you waiting while I'm drawing. Meihua bought 3 t-shirts at N dollars each. We want to express the total cost of t-shirts in terms of N. So the first thing we want to know is how much is the cost? Well, there's a bunch of different ways to write this. You could say that there are 3 n's, 3 times n, or of course, as you know, 3 times n or n times 3 is the same thing. Sometimes for math we use a dot instead of an n, and occasionally I just want to make sure that students know that a little dot is a multiplication symbol. And you know, in this case we even could write it just like 3n, because what we mean by 3n is n plus n plus n. 3 times n, it's the same thing. So all of these are different ways to state the answer, any of which is correct. I would say that this one is the standard form. We generally would say that it's equal to 3n. And then, of course, once again, when they give you a number to use as a nickname for n, For example, if each t-shirt is $8, then 3n is the same thing as 3 times 8. Another way you could write it. And we would say that that is $24. And again, putting your answer with units in a box is going to be a really helpful thing to do, to just be in the habit of doing for the sake of later math classes. Number 4, if a total height of 4 girls, so their girls are just, maybe we should do it sideways, right? Here's the girls, they're laying side by side by side by side, and here's the end of the first girl, second girl, third girl, fourth girl, and we're going to find their average height. Well, an average height, and by the way, this is W centimeters long, an average, very good definition to have really handy and mentally, an average is the sum over the total number. So exactly according to that formula, the sum, or the total height in a sense, the total height is W, the sum of their heights is W, the total number of girls is 4, so we would say W over 4, it's a division problem, it's a fraction, fraction means division, W over 4 is the height, and you have to, in addition to that, write centimeters. Crossing pages is hard to do. So if I were to answer this, the total height expressed in terms of W is W over 4 centimeters. That would be the answer for part A. So in part B, if W is 592, and you're trying to find the average height of the girls, then 592 divided by 4 is going to be how you do that. Now, we've talked a lot about division. Really quickly, I'll talk about my favorite way to think about division. When I see this, I think about it being 100, because I know that's 400 and 192. And then when I think about those tens, I know that I have 160 tens and 32 left over, so 4 goes into 160 tens, or 16 tens, 4 times, and then I have 8 ones. When I think about 592 being the sum of 400, 160, and 32, then the fact that it equals 148 is a pretty simple process. But there are other ways to divide. You could certainly divide using a long division mat or signs, and go through the process this way, and you'll never guess what you're going to end up with, right? 4 goes to 192, that would be 4 times because it's 160, and then we have the 132 like that. That's a very valid way to do it. When you're dividing by 4, it's a lovely trick to realize that you have to divide it by 2, which is pretty easy, right? That's 296, and divide that by 2 to get 148. So when you're dividing by 4, you can divide by 2 twice to get the answer. So that's 3 different methods to do it. Okay, and with this method, you might not even really write anything down. You might do all this and kind of hang on to this stuff mentally, and that's okay, but your student may not want to do that, like to do that, be able to do that, whatever. And of course, it's especially easy if it works out evenly, as this one does. Let's look at the next page, number 5. This part is very straightforward. You're just given the fact that n is 15. So each of these, you're saying if n plus 7 is 15 plus 7, that's equal to 22. Part C, 3n is 3 times 15. That's equal to 45. Part E, if you have n over 5, that's the same thing as 15 over 5. That's equal to 3. So we're just following the math skills that they give us to do. Not a big process or difficulty level there. Again, this is a longer recording than it will usually be because algebra is a new skill for us, but let's talk about exercise 2. I'm going to do number 2. I won't be doing all of the problems on these pages, but I'm going to start with number 2 because it's a little harder, and it'll be the same process as you could use for number 1, but I'll do the harder of these two. Vivian bought 6 bottles of cooking oil. She gave a cashier $40 and received Y dollars change. The first question is to express the cost of the oil in terms of Y. That sounds pretty abstract. So one good I guess it's a skill, right, or a tool. I like to say you put tools in your toolbox. One tool you could use to solve this is to make it concrete. So, for example, if you said to your student, okay, they gave the cashier $40 and they got back $2 change, and they bought 6 bottles. Okay, now what did I do differently than this one? Well, I gave us a number for change instead of Y. All right, your child could probably, if they've done Singapore math for a while and they've thought through things for a while, they could probably work this problem. It's kind of a work backwards. You say, I have $40, and then take away the $2 change means that we have $38. All right, now pause just a second because I set that up and I tried to get something that was going to work out right and I bombed. Hang on a second. I was doing all that in my head and I was trying to avoid one thing and I ended up messing it up. So let's start that over. Let's say you tell your child in a concrete way that they're going to have $10 change. That'll work out better. And so then they say, well, okay, if you give the cashier $40 and they give you $10 change and you've spent $30, and then you know that the cost of oil is, if there's 6 bottles, right, that bought 6 bottles, so take the 30 and divide by 6 and you know that that's $5 for each one of them. Right? And so we could even do that in a concrete way and say, well, we have $40 and we have $10 change, which means that $30 of that went toward the oil. And if that bought me 5 containers of oil, then I could see really quickly, sorry, bought me 6 containers of oil, gotta get my numbers straight here, bought me 6 containers of oil, and I could see that means that I spent $5 on each of 6 containers of oil, and those 6 containers plus the $10 goes back to the $40, and that's very concrete. Our kids have done this. If you're in primary 6 and have done Singapore math for a while, they've done problems like that forever. Now all of a sudden we're going to say, okay, what if instead of telling you a number for change, we say Y? And we say, okay, then that means that the expression is going to be 40, take away Y, that's the change. You're still going to divide it by 6 because we know that that's how many bottles we purchased. And so the cost is now going to be 40 minus Y divided by 6. And we know that because if the change was 10, we'd do this. If the change was 2, like I had, we would put a 2 in there. Now we'd come up with an answer that would have decimals, right? Change instead of just even dollars. And so when you come up with this, it's very easy to put in a number for Y and solve it. And then, look what I sort of accidentally, sort of on purpose did. Part B, Y equals 10. They want to know the cost of a bottle of oil. So sure enough, we fill it in, and not surprisingly, if we put it into the equation, and we write the equation down correctly, 40 minus 10 over 6 is 30 over 6, which is equal to 5. And so that's how much money you paid per thing of oil this time. Now, part C adds the complexity that you would expect with primary math 6. If you have 40 minus Y divided by 6, and if Y is equal to 1, 40 minus 1 over 6 is 39 divided by 6. That doesn't go in evenly, right? And so what do we do with that? Well, we know that 39, if you divide it by 6, that's 36 and 3 left over, right? If you've done math with me, you see that I do this division. This is how I mentally think about it when I do the mental math, right? And that's going to give me 6 whole things, and then this 3, if I divide that by 6, it's a half, or 6.5, or $6.50. And so mentally, if your child can handle the fact that 39 is 6 whole ones and 3/6 of another one, maybe they want to do the division. It doesn't help a whole lot this way because you still end up with a 3 remainder, and you can call it 6 and 3/6, or you can go ahead and divide using decimals. and end up with 0.5. Either way, the bottom line of this is that you're going to have the solution of $6.50. All of this should be fairly obvious to your child to get $6.50 when they divide that. And again, as I said in the intro, as you're deciding what to do for next year, these are the kinds of skills, not necessarily the first week of school, but these are the kind of skills you're watching for. Are they really solid on it, or could they use another year in a pre-algebra class to prepare for it? If they're solid, great. Go for algebra. If they're not so solid, then certainly this is a good time to begin deciding what to do for the next year. All right, let's talk about the problems on the right side of that page, number 3. This is all about really order of operations. They're similar to the problems on that the page 7 that we just passed, but it is a little bit harder because order of operations comes in. They tell you that k is equal to 6. I'm going to work the problems going down the right side of the page. Number B, letter B says 15 minus k over 3. And if we make that 15 minus 6 over 3, remember the order of operations tells us that we're basically going to simplify this part before we do the division. In order to divide by 3, we have to have a number that we're going to divide by 3, and that would be 9. 9 divided by 3 is 3, and so 3 is the answer for part B. On D, 10 minus 2k over 3, again, it's all about simplifying first. So that's 10 minus 2 times 6 over 3, or 10 minus 12 over 3, which is 10 minus 4, which is equal to 6. Do they have to show every step? Not necessarily. If they can be accurate and not show every one of those, that's okay. I want to make sure that you understand exactly where my numbers come from. And so I'm showing every possible step. K minus k over 6 is 6 minus 6 over 6. Sometimes the easiest things are the most befuddling to us. 6 over 6 is a fraction equal to 1. So that's just 6 minus 1, which is equal to 5. Continuing on with 3, letter H, 50 minus k squared. Now, k squared is always confusing to students. We really have to make sure that we understand that k squared means k times k. And since k is equal to 6, not 3, it's 50 minus 6 times 6. Now this is really where order of operations comes in. Order of operations, I referred to it a while ago. We do please excuse my dear Aunt Sally, or I've heard people call it PEMDOS. That's okay, whatever you want to say. We have an Aunt Susan, so we've always called it please excuse my dear Aunt Susan at our house. And the idea is we don't have any parentheses in this problem. We do have exponents, so we're going to solve this part first. And that is, of course, also kind of the multiplication part of it, so it works the same. So I have 50 minus 36. Once I've taken care of the exponents, which includes the multiplication division, now I'm going to do my subtraction and come up with the fact that 50 take away 36 is equal to 14. Letter J, 3k squared plus 20 is 3 times 6 squared plus 20. Really, really important. Does your student know that this square sign only applies to the 6? We're not squaring the 3, we're squaring this k, which is the 6. So effectively I have 3 times 6 plus 20, and 3 times 6 is 108, plus 20 is 128. Now, how do you do this mentally? 6 times 6 is 36. I have 3 30s and 3 6s. That's one way to do it. 3 times 6 is 18. 18 times 6, I have 6 10s and 6 8s. That's another way to do it. If your student needs to write down the intermediate steps, that's certainly fine. They can do that as long as they feel like they need to. But as soon as they can, of course, we're just kind of working towards being mental math as much as possible when it makes sense. Exercise 3, we're just combining terms. And so, again, I'll work the right side of the column. When you have y plus y plus y plus y, what I have there are 4 y's. And we write it exactly like that. When you have p plus 5p, again, I call it so easy it's hard. There's an understood 1. I have p. I have 1p, right? If I have 1 of them and then I have 5 of them, then altogether I have 6 of them. Just like I have 4 of these, I have 6 of these. And what I have in this case is a p instead of a y. On f, if I have 5 of them and I subtract 1 of them, what I have left is 4 of them. What are the them in this case? They're y's. 5y minus y, or minus 1y, is 4y. H, 7e, take away 3e, take away 2e. I started with 7. I lost 3 of them. I lost 2 more of them. I end up with exactly 2e. J, I have 5k minus k plus 2k. Follow the logic. 5k minus k is 4k. So when I work on this one, I get 4k. But then I'm going to add 2k, and that means I have 6k. I think it'd be awesome for our students to understand that all together I'm increasing, or I have a total of 7k's, and I have 1 to get rid of. It's going to give me 6k for an answer. I can also say if I have 5k and I give 1 away and I get 2 back, that's the same thing as just adding 1, right? If you give 1 piece of candy away and somebody gives you 2 pieces of candy, your final answer there is you gained 1 piece of candy. Lots of ways to do it. Always good to show it and say it in multiple ways. Number 2, part B, we have 6 and 5a and a negative 3, or minus 3. 6 and a minus 3 come together, and we end up with 5a plus 3. Generally, we put the numbers first, the variables first, the numbers last. 5a plus 3 instead of 3 plus 5a. Not a big deal either way. Either of those answers is perfectly correct. Letter D, 4a minus 2a plus 5. This time, I have 4 a's, and I'm getting rid of 2 of them. On this other one, I had 6, and I was getting rid of 3. The a's didn't change, right? In this case, the 5 isn't going to change, but I'm going to have 2a plus 5. Letter F, 18 plus 6f minus 9. What combines? Well, the 18 and the minus 9 are going to come together to give me 9, and then I have plus 6f. The 6f didn't change. Nothing affected it. Nothing moved it. Letter H, 9a plus 1 minus 3a. The 9a and the 3a are going to combine to give me 6a plus 1. Last one on this page, letter J, 15x plus 8 minus 10x minus 3. Good for them. They gave us a stretch problem at the very end of the workbook on this. I have 15 x's and I get rid of 10 of them. When I'm finished with that, I'm going to have 5 of those left. But I have 8 whole numbers, 8 whatevers, and I take away 3 of them. That means I have 5 of them left. So you can combine numbers and variables as long as they're alike. We call that like terms. We're not really using that terminology today. We're just kind of seeing how it looks and going from there. All right, again, I keep apologizing. I just want to make sure you know how this goes. This is intensive practice. I'm going to start talking about those. We're going to talk through 5 pages in the intensive practice book. And again, it's super long today because we have a new topic to cover. They won't all be this long. Number 1, notice what they've done. Such a great job. 1A, they talk about if you find a total weight of these 2 guys, then one of them's 35 and the other's 29, so you're just going to add it together and it'll be that many kilograms, and according to what they show, it's 64. So if in part B you've got a mom and a girl And instead of saying how much the girl weighs, they just put a G there. And so when you combine them, what is their total weight? It's 40 plus G kilograms, which, guess what, is still just 40 plus G kilograms. You can't simplify it, you can't put it together, you can't do anything to it. That's what you have. Okay? And then they make the point on number 2. It's just a lovely thing. If you have something that is 12 centimeters, and then you have a ribbon that you know for a fact is exactly 4 centimeters shorter, then how long is the ribbon? Well, if it's 4 centimeters shorter, then you're going to get rid of some. You're going to do 12 minus 4 centimeters, or 8 centimeters for that ribbon. But then you go over to part B and it starts talking about this big silo in this house. And we don't know how much the house is, but we know that the entire silo is F meters, and we know that the silo is 36 meters taller than the house. So the house would be the entire value of F, this whole height, without that part. That's the price of the house. And again, if your students can just see how tangible it becomes, this height, right, this whole thing, take away this part. Matter of fact, let's just erase it. It's gone. 36 without that part, I'm sorry, F, without 36, leaves us with the height of the house. Very, very logical and practical. Number 3 is more combining the like terms, just like we did in the workbook. We just did all those problems in the other one. I would like to work letter I just to make sure that this doesn't cause you or your student any frustration. Just like before, the 15 and the minus 9, if you have 15 and you take 9 away, you're going to have 6 left. That's not hard. What is interesting is, what does this mean? You have a minus 3G and a plus 9G. The idea here being that you have something and you can give something away. So if I give away 3 items and then I get 9, essentially what's happened is I've gotten 6 items, 6 Gs. Now, in our regular world, I can't just give away things I don't have. But let's just look at it in a minute in this way, and this will be kind of a little bit of dipping our toe into integers. As I said, integers is something, I don't think I've said it yet actually, but integers is one thing we don't do as much practice on, and we could do more practice on it for Algebra 1 if you're going straight into Algebra 1. But this is kind of how it looks. This is a negative 3G, or 3 Gs that are negative. These are 9 Gs that are positive, and just like a magnet, so many of your kids understand magnets a little bit, a negative and positive really cancel each other out. And so what I have left when I combine those are 6 positive Gs. So the thing that makes that a little odd is we start with a negative. If they had written it the other way, right, if they had said 15 plus 9G minus 3G minus 9, it wouldn't have bothered us so much because we understand what to do when you have 9 take away 3. When they write it the other order, it makes our students pause a little bit. It's the same thing. It's the same idea. Don't let them get confused. Help them to feel comfortable with numbers and realize that that doesn't change anything when you put it in the other order. All right, going on to number 4. This is the kind of problem we've been doing forever. We just have a variable in place. May is 11 years older than Amy. Amy is Y. If Amy is Y and May is 11 more than that, how many times have we drawn this kind of a drawing, right? How old is May? Well, we don't know a number. We just have to say y may is y plus 11 or 11 plus y, and that's how old May is. So the first several, this is letter A, the first several of those are just that basic. Let's go on to F and say one thing about letter F. Mark's height is 161. He's taller than Aaron. So let's do a height here. Here's Mark, and here's Aaron. Now Mark is 161. He's taller than Aaron by how much? By h centimeters. And the question is, how tall is Aaron? Well, Aaron is exactly 161 minus h, right? 161 minus h. And we could certainly say centimeters, that'd be good. Putting in parentheses is okay. Don't confuse your child too much with that. That's not a big deal. G says, I want to buy some cookies, and the cookies cost 7C. It might be $7, $14. Maybe C is $1.50. We don't know. But 7C. However, I only have $2. It's not enough. How much more money do I need? Well, I need 7C in all. Again, make it concrete, right? This is 7C. I don't know how much that is, but it's something. What I have is $2. This is what I need. How much is the part that I need? It's 7C, subtract 2, right? We know this. It looks odd to us with a variable. It's not hard. They can do it. We can help them think through it. Go concrete, go picture, help them to understand what they're doing. Letter H, an empty container has a capacity of 8 V liters. If 3 V liters is poured into it, how many more can be added? Well, this is 8 V, and we're pouring in 3 V, and you know what? Here's 8 of them. V, 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 V. V might be a thimbleful. It might be 10 cups full. I don't know. But there's 8 of them in my container. And what I know is that 3 is poured in. I've got 3. How many more can be added? Of course you can add 5V. Letter I is much easier if you make it concrete. If the perimeter of a triangle is P, and we know that 2 of the sides are 16 centimeters and 5 centimeters. I don't know this one. I'm going to call it S, and I'm going to call it centimeters. What I know is that the total of those, let's do it this way, right? The perimeter is 5 and 16 and S, and the perimeter is P. So if I want to know S, I would have to say P, take away 5, take away 16. That's how I get S. And I could even say P, take away 21. That's what that other side is. Letter J is very important. There are 10A apples in a crate. 4A of them are bruised. If 4A are bruised, they're either bruised or they're not. 6A are not bruised. Be careful though. What does it say? How many more good apples than bruised apples are there? How many more? There's 2A more. These are the good, and these are the bruised. Okay, and 2A is how many more good apples there are than bruised ones. All right, we're getting close to the end of this intensive practice assignment. Number 5, if you have 3 books and they're $4 each, then of course we know, we've worked on this for a long time, the total cost of the books, there are 3 4s, and that's $12. And when we go to the more abstract thing and we say, look at letter C, there are 10 cents per egg, and there are E eggs. E represents the number of eggs. Then the total cost of the basket is, the cost is 10 times E. If each egg is 5 cents, it's 10 times 5, or 50. If each egg is 1 cent, it's 10 times 1, or 10 cents. Right? It makes sense. We understand it when we have a number there. Sometimes a variable makes a head spin a little bit. Make it as concrete as I need to help them understand that I'm going to take the number of eggs and multiply it by the cost of the eggs, of each egg, and that'll tell me the cost of all of them. Number 6, again, works the opposite way. If you have all of those cups, if you have the 6 cups balances with 1,200 grams, then if you want to know what each cup is, you would have to divide each group into 6 equal groups, right? And so that would tell us that 1 cup would be 200 grams. So the same thing, if you take, again, we'll just go to letter C, the total value of money is M dollars. The value of each bill is how much? If there's 300 bills, then if I take the total value and I divide it evenly among the 300 bills, that's how much money each of them is worth, right? Again, you can make it concrete. Let's say you tell your student that I have a stack of 12 bills, and let's say the total is worth $120. Then they could figure out that $120 divided among the 12 bills is $10. That means they are each $10 bills, right? But if I change how much they're worth, or if I change how many of them I have, then my numbers change. But each time I'll divide the worth by the number of bills I have to come up with the value of each one. Again, make it concrete, help them to understand. All right, number 7, we wouldn't expect intensive practice to do anything if it didn't get intensive. Let me work down the right side of this one. If you have 22 B's and you have them 4 times, altogether you have 88 B's, right? Because I have 22 B's in this bucket, or in this bag. They're very crowded. I have 4 of those bags. Altogether, I must have 88 B's. B could be just like an animal, like a number, like a concrete something. It's a variable that stands for a number. But on letter D, it's different. D times D, that's not 2D, that is D to the 2nd power. By definition, when we have a number times itself, since there are 2 of them, it is D squared, D to the 2nd. Letter F says 10F times F times 6F. All right, we're kind of getting out of the things that we can just kind of draw a picture and understand, okay? But I have 10 times, don't forget, they didn't write it, there's an understood 1, but I have 10 times 1 times 6, and I have F times F times F. That gives me 60 F to the 3rd power. Letter H, when it says H divided by 18, a fraction means division. All I can do to simplify that and write it better is to make a division problem like that. And on letter J, I have 20K plus K divided by 10. According to PEMDAS, or order of operations, I have to do the multiplication division together, that one, before I branch out and do my addition subtraction. So this addition sign is going to come later, right, after I'm finished with something else. I'm going to say 20K plus K divided by 10. And in the back, it leaves the answer in that format. It doesn't ask us to find a common denominator and solve anything else. So we'll leave that problem with that answer. Number 8, let's look at doing those problems. We're either going to fill in with add, subtract, multiply, or divide. And let me remind you, these two will make it increase, and these two will make your answers decrease, right? So B says 6b squared is equal to 3b, and then do something to a b, and do something to a 2. Well, in order to get 6 out of 3 and 1 and 2, I had to multiply. And then check that and make sure it makes sense. B times b is b squared, so that works out just fine. Part D, 12d squared is 2d, and then do something with 2d, parentheses, and then do something with 3d. Notice the key to this, the big thing to notice, is that I have a d squared for an answer. If I have d squared, I only had d times d, although 2 times 2 times 3 is equal to 12. If I did 2d times 2d times 3d, I would have 12d to the third power. D times d times d is d to the third. So since my answer is supposed to be to the second power, I need to come up with another method. And what works is this. 2d plus 2d is 4d multiplied times 3d gives us 12d squared. And so they do work. Sometimes they look complicated, but they're possible to do. Don't give up on them. This problem, letter F, tells us f over 36 is equal to f, and do what to get 36, and that's simply division. I always say a fraction means division, and so when you're trying to solve something that's a fraction, make sure you know that you can divide those two numbers and be in good shape. All right, letter H, they like to end with a bit of a brain buster. If you're trying to get 20 minus h over 4, and you have parentheses 10, and another 10, and an h, and you're going to do something with 2 and 2. Okay, so notice what this is. I need to have a 20, and then I want to subtract, and what I want to subtract is h. So when I see that, I notice that in order to have 20, I need to have 10 plus 10, and then if I'm going to subtract h, I need to have that. And the parentheses really explain it to me here, because this whole thing in parentheses is my numerator, and my numerator is going to be divided by, because of this line, I'm going to divide it by the denominator. And guess what? Are they being tricky or nice or funny? This is 2 times 2 is 4. It's also 2 plus 2 is 4. You could have plus or you could have times, and either answer would be correct. All right, so now I didn't do all of the problems. If there's one that I didn't do, if you'd like me to go ahead and work the other side of each of those or whatever, let me know. I'd be happy to post recordings for those if you need more help with them, or if there's one you get stuck on. And but I'm sure drawing on the past experience and what you're doing, you can do this. Just don't let the word algebra be a confusion for you. And I will do the challenging math word problem assignment in a separate recording. Thank you very much.